Today's presentation is about API automation. Originally, we're supposed to have two ladies to support you with this session, Jermaine and Nicole. However, because Jermaine is unwell today, so she's not able to join us. However, you still have Nicole taking you for this session. But I do want to recognize the effort of these two ladies. So I'll run through a very simple introduction of Jermaine, even though she's not here, because she's actually helped to prepare like half the deck here. So Jermaine studied computer engineering in NUS and she graduated in 2021. So she joined TikTok in the same year, working first as a front-end software engineer, and then later on moving on to the testing platform within TikTok. So in her free time, she enjoys traveling and swiping TikTok videos. So if you'd like to know more about Jermaine, feel free to check out her LinkedIn profile over here. Okay, and then Nicole is present with us today. So Nicole has a bachelor's degree in computer engineering. She's got like 9 years experience as a full stack software engineer, so a lot to learn from her. She started off with TikTok in 2021 as a wallet front-end engineer. And then in 2022, she moved on into the testing platform engineer role. So if you want to catch up with Nicole, you can check out her GitHub profile as well as her LinkedIn profile. So I know in the maybe past few classes, there has been people asking like, how do you transition from a front-end role, a back-end role into testing or even SRE, right? So you can probably ask some questions to Nicole, you know, how was the transition like, okay? So I will hand the mic over to Nicole. So Nicole, you can take over from here.
Hello, do you hear me?
Yeah. Yes, very well. Thank you.
Maybe about the transitioning, maybe that answer will be later. Maybe we can save it for later.
Yeah. I just prompt them in the beginning so they can start thinking.
Okay.
Yeah.
Okay. So hi everyone. So I'll be covering API automation from the UI like another perspective of automation. So today we'll look at 4 topics. So the first topic is API automation tools. The second, we'll do a demo with Postman. The third is load testing, and the fourth is measuring automation. So this is actually not for API only, but both for UI and API. Okay, so let's start with API automation. Okay, so API automation, put simply, it's very similar to UI automation, but instead of automating the user end-to-end interactions, we validate the response data. So so we simulate API requests and validate the response data. So why use API automation if UI automation covers almost UI automation should cover API automation as well. So first thing is efficiency. So API automation is generally faster, not just faster than manual testing, but also faster than UI testing. So I'll cover that more later. Then we have accuracy. So this one is more of a general, like a general benefit. So accuracy is automated tests are less prone to errors compared to manual testing. So it can help us catch bugs and issues quickly, consistently, reliably. The third one is integration testing. So because now, as you guys know, maybe in the backend section, like the backend is very complex. So there's many microservices working together. So actually API testing sort of helps with integration testing because there's different services in the backend working together. So by pinging one API, we can see how these different APIs work together and if they are working as expected. And then the fourth is regression testing. So regression testing, like what was covered in previous sessions, is just to cover like existing functionalities are working. So this also goes for all types of automation, not just API. Yeah, so like I mentioned a while ago, if UI automation validates API responses, is API automation still needed? And the answer is yes. So the reason is API has different consumers. So not only the web, not only the mobile consumes the API, but we also have microservices. Sometimes we have like third-party apps calling our API depending on like your application. So it's always good to have API testing. Second is faster than UI automation. So if you've seen the Yuntao's demo, like we have to start up the app. So we have like, there's a lot of process, like you can imagine doing it in the cloud. Like the time needed to set up the app, it does add to the device cost. So API automation is definitely faster than UI automation. So as you guys know, like you can call an API just from your terminal, like you can do curl. Yeah, so very simple. And then, yes, the last one is easier to debug and to pinpoint errors. So like earlier, Yunta was testing the weather app. So if there was an error in the weather API, like if we got it from the UI test, we would wonder, where is it from? Is it from user interaction or is it from the API? So if we have API tests to complement this, then it would be easier for developers to pinpoint where the error is. Yeah. Okay, so tools, yeah, Tech has a lot of tools out there. So we chose Postman just because I feel like many people know Postman. Maybe you can raise your hand if you know Postman. But yeah, so oh, that's great. So many people. Yeah, so it's a very popular API development tool. It's not known for testing. It's known for like just testing your APIs. So, but we hope that we can give another perspective to Postman. Yeah, so if you're a Java user or like you're more used to using different types of languages, there's different tools like JMeter, SoapUI, Rest Assured, Karate, which you can check on your own time. Okay, so let's go to the fun part, demo. So for this demo, I'll be continuing with Yuntao's demo, which is using the Singapore government API. So it actually uses the Singapore government API, the weather API. So yeah, you can check it out here. Maybe I don't know if you can see my screen. Oh yeah, okay, yeah. So yeah, so it's a public data set. So it's actually good for like trying out small little things. Just because it's public, there's no authentication. So it's always easy to get started with these type of APIs. And then the good thing is their APIs follow the Open API specification. So if you've heard Swagger before, yeah, they have Swagger and it's in their GitHub. So, oops, what the, this thing is blocking the way. Sorry, yeah, this one, okay, sorry. Tech issue, yeah. So they have a Swagger Open API, which lists all their Open API, which lists all their available datasets. So yeah, just a brief intro again on Open API. It's a specification that defines a standardized way of describing APIs. So maybe if you're like integrating with payments or any other third-party API, high chance they use Swagger or any type of Open API specification. Yeah, it provides machine-readable description of endpoints, parameters, responses, authentication, and other details of an API. So basically, anything and everything you need to know about API. This was just extra jargon, I guess, to prepare you for the demo. Postman collection is just a set of HTTP requests that we can organize into folders. It consists of a series of requests that interacts with the API, and yeah, basically it's just a group of APIs that we can use to better, like, you can think of it like test suites. If we make it in a, like, if we want to make test suites, we can organize it in a Postman collection. Okay, so for my first demo, I'll be showing the benefits of Open API. So with Open API, because it's standard, you can easily auto-convert it from like an Open API YAML file to a Postman collection or with tests. So if it sounds like magic, it's all because of this this app here, it's called Postman. Yeah, so Postman is open source, so you can find it in GitHub. So basically, it ports Open API specs to Postman collection plus tests. So yeah, so actually it has a lot of like benefits to it, but just to highlight is that it injects like Postman contract tests, integration tests, etc. So yeah, if like for example, if you're joining a team with an Open API spec but they haven't tested anything yet, then this tool would be a good scenario for you. So let's start. Okay, so the prerequisites for this is that we have to install, which I already did to save some time. And then second is we can generate the Postman collection from the Open API spec. So actually, I already copied it here, but it's actually from this website here, so you can copy it as well, which is the data.gov SG Open API. So let's run the command. This one, L stands for local file. So we saved it in data.gov.yaml. So let's do that. O is for output. So we want to keep it clean and put it in the collection folder. So I already have it here. Let me delete that. Okay, like some errors, but it's fine because I guess they didn't design the YAML. I mean, maybe some parts didn't meet the OpenAI spec or what Postman is expecting, but it did generate this JSON file. So this JSON file, we can actually import it in Postman. So just import files. Yeah, so let's wait. Oh yeah, so super quick. Yeah, so you see that they have all the APIs already. So super simple to get the APIs. So let's look for the weather one, which is this one, 24-hour weather forecast. Yeah, let's try something. Okay, so it says invalidate. I guess this one, the current Swagger file can be improved. So let's try it again. Okay, there. So yeah, we have the API. And if you see here, I don't know if you've ever noticed this feature in Postman, they have tests. So they actually write it for us. They have the basic test, which is to validate the status, to get the response headers, like to ensure it's JSON. So basically, it highly depends on how good your Open API spec is. So if you run the test, like you can actually see it here. Yeah. Yeah, so this one is a very simple example of like how we can, like if we're in the scenario where the team has Open API spec, but we have no tests yet. So for the demo 2, what if you're building a team has no Open API spec, you have to go fast, like you have to get things done quickly. So I'll just make a demo of how to make it from scratch. So hold on. Okay, so yes, I guess this one is just very very simple. So maybe we just want to do the weather API. And then oh, I don't know. Sorry, this one. Okay. So maybe just using the Swagger again, we just copy the API URL. And then we check for the weather. So the good thing is there's no authentication, so we can just save it and see if it works out of the box. Yeah, so that's great. So, oh, I actually got the 2-hour one. Yeah, it doesn't matter that much, but we can try another API. Yeah, okay. I'll just rename this because we'll be reusing it later. So actually, Postman uses JavaScript. So sorry to be so confusing because it was used Python at first, but I guess Appium does support JavaScript. So if your manpower is limited to just like JavaScript engineers, then I mean, you can use Appium in JavaScript and use Postman, but it always depends on the current situation and the current knowledge of each engineer. Okay. So before I start writing tests, maybe let's go to some basic concepts first. So for all automation, like assertion is important. So yeah, Postman assertions can be easily added in the test script using JavaScript. Okay, so this one, I'm not sure if it looks like jest. So there's like test. So it defines the test case, like what is the name of the test. And the second parameter is the function. Expect is what we expect in a value. Two is like BDD. So it's behavior driven development. So if you want to make the test read like English, then or like business use cases, then many people use two, but it's quite optional. Equal status, yeah. So I think most of this is more useful when we try it out. But yeah, there's the status, the header, JSON text match. So if you look at Postman documentation too, there's even more assertions that we can use. Yeah. Okay, so maybe I'll skip this and we'll just write it. So usually for API test, I mean, the very basic that we use is we want to like test the response code. So like, for example, if we're doing a post API, then it should return 201 or like created, or if it's just a get, then always return 200. So that's good. Should return status code 200. And then, so PM is the like Postman. So we actually here you can see everything that you can assert with. So we're just doing response to be successful. Yeah. So if you can see, like, if you're a newcomer, like reading the code, this one is very readable. So it's part of like one of the testing perspectives is that your test should read like business logic. So yeah, it helps to be readable. So let's send this first. Okay, so the weird thing is that the test results appear here, so that's good. Then let's write another simple test. So let's look at the body. We just want to, let's say like other apps depend on our API, so we always need the items property in our test case. So should return items. Yeah, we can do this. PM. Okay, so we can keep the response data. Yeah, so we can JSON, and then we can expect the response. Property. Okay, so let's just do this simple one. Yeah. Okay, then we can go a bit further and say that the length. Yeah. Yeah, so we can say that it must have data because I guess 24-hour weather forecast, it will never be empty. Yeah. So just to make sure that it doesn't pass all the time, I'll just show that it feels. Yeah. Yeah, so that's a very simple way. So hopefully the goal of this is just to promote more people to testing. So it's not very, like, I hope it shows that it's not very hard to get an API, like a simple API test setup. So definitely there are many more challenges, like especially when it comes to post data, like we can't keep creating accounts, or we can't keep creating basic resources. So this one, we need to cooperate with different teams, like the infrastructure teams, to help us prepare like an environment. But for now, we won't cover, unfortunately, we won't cover this for now. Yeah. And then, okay, the last one is monitors. So it's not really automation if it doesn't run like consistently or in a schedule. So Postman actually has everything, like almost everything that you need, like the very basics to get you started. So it's like a cron job and we can run tests automatically. So I'll show it super briefly. Yeah, so we can just check the API. Yeah, so we can choose if it can run a week, hour. So let's just do an hour, maybe every hour. So if you want to go like to the minute, so maybe if you're doing like some financial systems or very, very high, like, then you can use the minute timer. Good thing is it also has notifications, so you don't have to develop it yourself. Let me just create the monitor. Yeah, then you can run it. Yeah, so maybe like in the next few hours, we'll get more data here. But as you can see, it only took the test to run like less than 1 second, so very fast. Okay. Okay. Yeah, so I think that's just the basics for API automation. So if you're wondering if like, what if I don't want to use like Postman monitors, or I have like the team I'm in already has CI/CD in place, then Postman actually has something called Newman CLI. So we can run the Postman collections in command line, so we can integrate with GitHub Actions or any other CI/CD. Yeah. Okay, so to summarize the API automation benefits, so it's fast, and the main goal is fast to run compared to UI, so we can run several tests quickly. And then it's good because we can easily prevent regression bugs. So this is just more of like, if you have high coverage, then we can run the tests frequently, like whenever a developer pushes, so that we can always ensure that our new features don't introduce new bugs. Yeah. And with this demo, I know it's very simple, but I hope that it helps you get started with testing APIs. So they provide tests and monitors. Okay. Oh, sorry. So I think that's the first part for the API automation. So should I check the questions? Maybe I can check the questions first.
Well, it's really nice of Bintao, and so we did have to clear a lot of the questions. Yeah, but I see a hand raised. Let me see, who is it?
Okay, wait. Let me...
No, I think it was something by mistake. Yeah. So I think because Nicole is still going to be around for the next half, so I would like to suggest for all of us to maybe take a short break, if that's okay with all of you. We come back. Okay, now it's 7:47. Can we come back at 8 o'clock for everyone? Okay, there's one question, Nicole. Maybe we take that one. How does TikTok use Postman for API testing? Okay.
That's a good question. So it really depends on the team, because each team we're not but we're not very strict with the technology we use. So it always depends on the team, like what works best for them. But definitely Postman does have some limitations. So I don't although in my team we don't use it, but I guess we just use it as an introduction for now, because it's like a very simple way to get started with Postman. For the tools we're using, I'm not sure if we're able to disclose. maybe Motomi you can mention, but
Yeah, if there are some open source tools, I think it's fine, but it's company developed. I think, yeah, we are not able to do that.
yeah, we're not able to discuss, but definitely it's very like close to open source concepts. So like the things you learn from like open source programs, you can port it over to like working in TikTok.
Okay, thank you, Nicole. So I'm going to suggest that everyone today, I think we can be a bit more generous. I'll give you a 12 minutes break. We all come back at 8 p.m. for the next half of today's session, all right? So 8 o'clock.
Oh.
Yeah, so same thing for the speakers. You can take a short break and then we come back later on. Hey, welcome back, everyone. So I think, Nicole, you can take over from here where we last ended.
Okay, hello. Yeah, just checking again.
Yes, you're still good.
Okay. Let me share. Oops. Oh, going a bit too far. No? Wait. Okay, so I guess we can start. So today I'll be talking about load testing. So it's another variation of API testing, because if you recall from session 2, there's actually something called performance testing, and load testing is one of them. There are several tools for load testing like JMeter, Locus.io, Artillery.io. Oh, actually, wait, I'm sorry. I feel like something wrong with my slides. Oh yeah, okay, sorry. Let me restart. Okay, yeah. Okay, so yeah, to recap from session 2, load testing is helpful to evaluate the system performance under different loads. So you know that user behavior varies over time. So load testing can give us the confidence we need to ensure APIs can handle the expected load. So it helps us to detect the slow response time. Like for example, if we have a requirement that our API needs to return in 100 milliseconds, poor scalability, poor scalability is usually, you see it at the back end, but in the front, in terms of response, we see it also in like the response time if it's too high. And system crashes, maybe if we just see an error 500. So yeah, that's the benefit of load testing. And maybe just to add, load testing is more of the expected load. So it's not like stress testing where we, stress test like the maximum or like DDoS attacks. So maybe just to reduce some future confusion. Okay, so yeah, so we want to continue with the same tool, which is Postman. So Postman has something called collection runners. So they allow us to add like iterations, like how often we run our APIs. But then that would mean that our APIs or like the request would look like this, which is a straight line. So like we're pinging the endpoint consistently like per 1 minute. But that's not what we want, because yeah, user traffic can look like this. So like, for example, we're buying concert tickets. So maybe many of you have tried to buy concert tickets before. So like when the ticket opens, you can expect a spike like of users waiting to buy tickets. And then when the tickets are sold out 5 minutes later, then it slowly dwindles down. So you can imagine the load of the system is from 2000 to 0 very quickly. Yeah, this one I said load testing doesn't we don't do like stress testing, but this is just an example. So user traffic can also look like this, like malicious DDoS attacks. So DDoS attacks is denial of service, where attackers just spam your system. So this is actually quite common. So if you want to just to know how much your system can expect, then we can use load testing to test that. Okay, so yeah, this is just comparing how the real user traffic looks like. So yeah, like I mentioned earlier, load testing, there are several tools like JMeter, Locus.io, Artillery.io. But in this case, we're choosing to use K6. So the reason why we're using K6, I'll share a bit later. But the funny thing is, in tech, things change very quickly. So when we were creating this presentation, Postman didn't have any type of performance testing, but I know that Mayank from the last session, he also mentioned that Postman recently released performance testing. So it's still in early release, not yet fully available, so you have to request for it. It was just released last month. So if you want to try it out in the future, feel free to do so. But for now, we'll just continue to use K6, just because we don't have access to the early testing phase. Okay, so why K6? Running joke is because of the GitHub stars, but though it is one reason, so the other reason is because K6 is actually scripting in JavaScript, but JavaScript is known to be slow. So it actually runs in Go in the backend, but the tests are written in JavaScript, as you'll see later. And then the good thing about K6 is that it integrates well with Postman. So they actually have it in their website. Like you can see the link here. So they have a Postman to K6 converter. So if we have if you remember the JSON collection we can easily convert that to a K6 script. Okay, so yeah, just so that so that we understand it more, let's do it to a demo. So I'll be doing two parts to the demo. So the first demo is to convert the Postman collection to K6. And then in the second demo, I'll be running the load test. So in the load test, what we can expect is that we're testing the government APIs if they return faster than 100 ms. So why 100 ms? So it's not a magic number. So there's a Nielsen Norman group, which is basically like a UX consultant group. You can check the links, I think, in the course materials. But 100 ms is the threshold for responding instantaneously. So for a user to say that your API is fast, it should return in 100 ms. Yeah. And then what we'll do in the load test is, I don't know the expected load because it's not our API. So we're just using the API for ease of demo. But we'll do something simple. So we'll ramp up from 1 to 50 users and go back down to 0. Okay. So give me a 1. Okay. So let's start with the first one. So to get started with K6, I already did the prerequisites, which is to install K6. So it's not a node module. We have to install it because it uses Go in the background. And then we have to install the Postman to K6 module, which will convert our collection into a K6 script. So let's do that first. Okay, so yeah, this is the reason why I named it well a while ago. I hope I named it well. So we can export this collection. Let's name it okay, so I'll save it under data. Okay, so it should be here. Oh. Okay, so first we downloaded the collection, Environments, we don't have any environments for this demo for simplicity, but if you're familiar with Postman, they do have something called environments, which actually, if you look at the data.gov.sg, yeah, it can help you test with different environments like pre-production, UAT, or production. Yes, but we'll not cover it for now. So, okay, let's convert. So I already have Postman to K6 installed, and then I'll call this data, and I'll output it to a test script. Yeah, see, so instantaneously, we already have like a K6 script ready. So it's not the best script, but it, like maybe you don't prefer this syntax, but it's auto-generated, so it's easy for us to get started. So it uses the default option, so maybe it's better if I run it. So to run the test, we just call K6 run and wait for it. Okay, yeah. So basically you see, let's look at the data here. It gives us a lot of like metadata to the response that we don't usually have. So like we have the request duration. So it takes a bit long, like well, quite short, 11 milliseconds. Yeah, expected response. Oh, this one is actually from, oh no, it's very simple. Sorry for that. It seems like the demo didn't include the test cases. Let me see if I can update it. Oh, I think it's because I didn't see it. Yes, but ideally it should also include these test cases. So let me just do it again quickly. Delete. Just for safe measure. Okay, so if you look at the default scripts, oh yeah, there. So it actually already incorporates like, so it's like load testing and the test if we want to keep them together. So it's just a good option to have if you want the load testing and the functional testing to be together. So this one is very simple. So I promise that we will do like a ramp up from 1 to 50. So this one requires a lot, like getting familiar with K6 tool itself, but the documentation can be found in their website. So it's quite maintained, so you can expect good documentation. Okay, so these are it's called stages. So we can just say like how many users we plan to have for a specific duration. So I made it start at 1 user. Then after 15 seconds, 1/4 of a minute, it goes to 25 users, then 50, and then 0. So the whole test is expected to run for 1 minute. So let's run it again. Let's see. Oh, is it too small? I don't know if it's too small. Okay, so let's just look at the running mark here. So VU is virtual user. So now we have 1 user. And then the 15-second mark, we can see that it will slowly ramp up to 25 users. Yeah, 25 users. So you can see the views. So it does the logic for you for simulating the user traffic. And then in the 30-second mark, we can expect it to ramp up to 50. Yeah. So yeah, then once it reaches 50, it will stay there for a while. And then before ramping down back to 0. So it actually gives you a good readable scenario here. So up to 50 looping virtual users for 1 minute over 4 stages. So there's some time for ramp down and stop. So if you see, actually the API is doing very well because it returns an average of 12 milliseconds. I actually did the test here. So if you're wondering how do I test that the request should be below 100 milliseconds, it's because of this key value right here. So we just want the P95, which is 95 percentile of our users. So we can't expect like 100% to return 100 milliseconds. It's just being I guess realistic. Yeah, but the common practice is to check them like 95 percentile. So you can see the government API did very well. Actually, some returned 1 second, but I think most of it returned an average of 12 milliseconds, which is good. So yeah, we can use these tests to help us understand how fast our APIs are, like maybe especially in scenarios where timing is important, like you can think of financial systems. These load tests will be like very useful, like not to just know how many users that your system can take, it's also knowing that they will have a good experience or like a good response time to have. Yeah. So yeah, again, it's a very simple demo. So maybe I'm quite scared. It's a government, it's not our API, so don't wanna stress them. Yeah. So yeah, actually, if you look into the K6 response object, they add this like timing, so you can test all of this. So the complete list is in the documentation. And then I haven't had the chance to add it to this, but maybe you're wondering like, what if I want to simulate different traffics from different IPs? So this one will actually need some infrastructure. So K6 does have a service called K6 Cloud, where you can say like, I want it from these different IPs. But from this demo, like when you're locally testing, it's just like underneath, based on the documentation, it's just like a while loop, like pinging your APIs. So if you want something more complex, like like to get different IPs or people from different locations, then you can use the K6 Cloud. Okay, so yeah, just a quick summary. Load testing is to test and maintain the expected system performance, just to make sure that like you're always returning like a response in a certain number of milliseconds. The problem is it is a long test. It's considered long. So you can imagine a developer can't commit and wait for 1 minute just for the load test to run. So usually load tests are run as needed. So maybe before big marketing events. So like in TikTok, it's known like if there's some marketing events, then load testing will be run. Sometimes, if depending on the team's capacity, if they want to run it once a week or every like once a day, then they can do that. But certainly not like unit tests or the API tests, which can be run more frequently. Okay. So we're done with UI and API automation. So now I'll go to a more theoretical topic, which is measuring automation. So
sorry, Nicole, do you want to like take 1 or 2 questions in relation to your earlier presentation?
Okay, let me take some questions. How should we gauge the number of virtual users to load? Okay, that's a very good question. That one is a business question actually. So you can like confirm with like your PM, like how many people do we expect to use our system? Sometimes it can depend also on like we do have other monitoring systems, but I think that will be covered on SRE. Like we know how many people usually use our like system. Like we have user data of the usage, so we can use that as a basis. So yeah, I hope that answers your question. Is there any algorithms or ways to optimize assuming our load test fails? That's if you recall, I think Roy did something in Go, like a test, like it does like a line analysis of your code, like where is it slow, where is it fast. So I think it's more of another tool to like to determine if the test is if like what we can do to improve your code base itself. Yeah, so I think you can refer to session 2. Session 2, meaning this Wednesday. Yeah. Okay, so is the performance for government better than TikTok? uh, yeah, Motomi will. I think the government API is doing good, but I think TikTok API is also doing good based on the user. So yeah, it's hard to compare because they're different platforms. Because the government API is more like it's not live data, or well, they're both like they keep static data, but I feel like they're very different use cases. Yeah. So, but I think based on the 100 millisecond rule, we can say the government API is better. For TikTok API, maybe we weren't able to test with the TikTok API, but maybe like a next time we'll add this to to improve the experience. Okay. K6 users while loop on local machine for underlying structure. Does that mean the K6 has limitation on number of requests depending on machine? Oh, that's a good question. Actually, I don't know. I don't know this answer. So maybe I can get back to you, but it's probably somewhere in the documentation, like if there's a request. I mean, worst case, it crashes. You can always try, but I don't think it will break anything, so it should be fine.
Yeah, so I think we can get back to this attendee offline.
Yeah, okay.
Yeah, thank you.
Okay, yeah, so now more on theory, so no demos for this one. So for measuring automation, like you can see like from Yuntao's demonstration and from the API automation, it's not very easy to set up automation. Like it comes with some costs. So we need a way to measure if the cost, if the return of investment is good, or if there are ways that we can optimize the automation experience. So yeah, it's a quantitative estimate of the testing process. There's several metrics out there, but in TikTok we look at these four. So I'll go through one of them later. And yeah, the goal is to improve the testing process and the future decision making. So like I think you've heard it a lot, like data-driven decisions. Yeah. Okay, so progress. So the easiest way to do progress is code coverage. So how many parts of the code have been covered? Higher coverage means more progress, more scenarios, and more edge cases are covered. But the goal is not to test the goal is not to achieve 100%, but to test the business use case. So internally, like maybe not in TikTok, but I think also in other companies, like it depends on the business, but maybe 80% is like a good baseline to have. Yeah, 100% like meaning to test every if else, it might lead to flaky tests. So tests that always like fail randomly, or it makes it hard to refactor your code. So just a reminder that it's okay not to achieve 100%. And then the tools available. So you can imagine E2E is harder to cover, like compared to unit testing, because E2E usually doesn't have access to the code. But for Web E2E, there's this cool tool called Puppeteer. I don't know if you've used it, but it has something called Puppeteer coverage. It returns the lines of like compiled JS and CSS code that are run in the page. So you actually know which code is running and which code is not. So yeah, you can explore this tool on your own time. For API, it's actually quite hard, but like a simple metric that we can do is to check which APIs endpoints are covered or not. So Postman actually have it in their Postman reports. So yeah, it's definitely a challenge to do with E2E, but knowing which API endpoints are covered or not is already a good metric to have, to know how much progress we have in automation. Okay, second metric is effectiveness. Yeah. So to measure effectiveness, we do defect detection, which is basically bug detection. So how effective are our tests in catching bugs? So like we can, yeah, so the higher rate is regression tests have good coverage, or like if the, sorry, yeah, regression tests have good, if regression tests have good coverage, most likely they'll have a high defect detection. So we can find it by the bugs found by automation over bugs, like total bugs, bugs found by automation and bugs found by manual methods. So there's a little star in bugs found by manual methods because we know that there are certain cases that we cannot cover by automation, or maybe it's too complex to cover by automation, like third-party login where we don't have access to their APIs, or they don't provide like a mock API. So it should be excluded from the defect detection rate. Yeah, so unfortunately for this step for us, we found it hard to automate because when the QA reports a bug, they need to determine if it can be found by automation or not. So what we usually do is we updated the project management software. So like Jira, like you can actually edit some fields, and then by this way, at least we can automate the data collection, but sadly manual tagging is still needed. Okay, test quality. So how robust are our tests? So yeah, so it's more of like every developer's like how good is our code? So how robust are our tests? So for test quality, we try to segregate between valid bugs and invalid bugs. So good test quality is valid bugs over like all the total bugs. So again, higher rate tests are more robust and less flaky. So some invalid bugs that we encounter is like device and infrastructure issues. So maybe like the cloud device where we're running our tests is not stable enough. Like maybe they fail, or they like cause some network issues. So that is called an invalid bug. And then another one is outdated test scripts. Like maybe the developer changed the selector, so which makes actually UI testing a bit harder. So this is also part of an invalid bug. So invalid bugs help us find what we need to optimize to keep our tests stable and to keep our tests like true. Like, can we believe that it is a true failure? So that's test quality. Okay, then fourth is maintenance costs. So yeah, all of this comes with a cost, right? So how much manpower and how much resources are needed to keep the current tests running? So for man hours, yeah, how much manpower do we need to update the test for new features and to update the current test cases based on the changes in the code? So this one usually is measured by like project management tools. So it's also requires a bit of manual work. For device and infrastructure costs, this is easier to measure. So the test execution time directly affects device costs. So like another reason why we don't always run load tests is that we need to understand if the cost of running it very frequently will return the benefit of like having a high device cost. So this is something that is also important to look at when running your automation tests. Okay. Yeah. So so we have those four like levels, but usually, like with so many business units inside TikTok, we want a way to simplify automation levels. Like, what's the status of this business unit in terms of automation? So yeah, it helps us simplify understanding of the organization or the business unit's current automation level. So Google, in their book, they have a book about software engineering. They actually touch on project health. They have something called project health, PH. Yeah. So they have 5 levels of testing. So if you're a level 1, you have the basic setup of automation. You have code coverage, mechanism, you have CI/CD. So it's actually a high bar. Level 2 to 4, they weren't very specific, but as you grow up the level, you actually have more coverage and less flaky tests, or like less invalid tests. And then level 5 is that we have small tests running during every commit, large tests before every release. P0 code coverage is 100% and no flaky tests. So yeah, so level 5 is actually like is a good goal. Okay, so TikTok, we actually have our own automation levels too. So we have levels 1 to 5 as well. So level 1 is, we call it like accidental automation. So automation has no obvious benefit. So it's more of like a burden rather than like the cost to set up, maintain, and to teach people, like the training cost is still high. So there is no obvious benefit to automation. Level 2 is what we call basic automation. There's some benefit. So at least 90% of P0 cases covered. So P0 is like the very, very like high priority cases. And 70% of bugs caught by regression tests are valid. Yeah. 70% of bugs are caught by regression tests are from automation. Okay, level 3 is actually the break-even point, where we can say that the manual regression by manual testers are almost replaced. But the problem is the maintenance of the automation tests are still high. So although we've reached the break-even point, there are still ways to optimize the test cases, like to set up like data-driven tests or to reuse the tests even more. Then we have advanced automation, where maintenance cost is low. So maintenance is like 10% of the labor of our automation tests. And then last is intelligent automation. So it's actually like level 4, but we have like smart generation of tests, maybe like using AI, like so that it will generate the test case for us. Yeah. So, okay. So yeah, then for tools, it's hard to recommend one tool because it always depends on the like the underlying framework that you use. Postman has one, but I think it's paid. If you want to make your own, you can use like other tools like Grafana to get from different data sources to visualize data or to visualize the current automation level. Okay, yeah, so that's a summary for, that's the end of the measuring automation. So just to summarize, automation levels help us give a simplified understanding of the current automation situation. So it's very beneficial for high-level leaders to see which business units need more manpower in automation, yeah, which business units we can learn from, yeah. And then it helps expose opportunities for automation, like improving code coverage, defect detection, test quality, and to reduce maintenance costs. Okay. Yes, so I think that's the end for the measuring automation. So maybe before I give it to Xiaoqing, I'll check. Oh, Oh, my LinkedIn. Okay. Yeah, I think yeah, I can share the link later. Yeah. But I
Yeah.
feel like, yeah, this is more on theory, so it's, yeah, maybe not very important for now, but hopefully it will be important when you start working, because yeah, metrics is always important to show like have you really achieved anything. Like it's a good way to prove like or a good way to how do you say it, like just to see if you're improving or not. Yeah, quantitative way. Yeah. Okay.
Okay, thank you, Nicole.